Hello, ladies and gentlemen. We're going to take a look at the chemistry of carbohydrates activity and just make sure that we understood the main points. So first off, through this activity, we saw that our building blocks, or a basic unit of all carbohydrates, were our monosaccharides. And we had three types of monosaccharides. So we had our glucose, our fructose, and our galactose. And they had the same molecular formulas, but their structures were slightly different. And we said that these are called isomers. So they have the same molecular formula, but their structures, if we look at them, are actually slightly different. So in this activity, we used the monosaccharides to build disaccharides. And we saw that they actually needed a little bit of adjustment in order to fit together like puzzle pieces. So in order for the two monosaccharides to come together, to form a chemical bond, we actually had to remove two little parts. So we needed to remove an OH from one of the molecules and an H from the other molecule. And I lost mine here, but I drew them in. So here's my OH and my H. We said that if those come together, so when those come together, they actually form water. So water, or H2O. And if you look, this actually asks you to label your molecules as well. So here we made sucrose. So I'm going to write sucrose. Let's quickly take a look at the other one. So on the back, I built the other disaccharide as well. I'm just flipping it over. And here we made maltose, and we just connected those two glucose molecules. So we saw that in order for them to have that nice fit, to form this nice chemical bond, they actually had to lose this H2O. So I'm again going to label. So this is water, and this here in this case is maltose. So this is maltose, a different disaccharide, so made of two smaller monosaccharides together. Now, for this part, for 1011, it asks us to write the chemical formula for maltose and sucrose, and we have to take the following into account. So originally, we'll look at our maltose first. Originally, our glucose molecules were C6H12O6. And we actually had two of them. So we had one glucose, and then we had another glucose. So C6H12O6. Okay? So we are combining these two molecules, but we have to take into account that we removed the one water. So we actually took off water, or H2O. So we know that just by looking at our diagram, we removed here two hydrogens and one oxygen from the disaccharide. So we're taking that into account when we calculate the number of carbons, the number of hydrogens, and the number of oxygens in our maltose molecule. So if we look for carbons, for our total carbons, we really should have 6 and 6 because we didn't remove any. So we should have 12 carbons. For our hydrogens, so looking at the hydrogens just for the maltose, we would imagine that we'd have 12 from one molecule and 12 from the second monosaccharide molecule. However, we removed 2 and they went to the water. So I'm going to start with my 12 plus 12, and then I'm subtracting 2, and those 2 hydrogens ended up in the water molecule. So if I look at the math, then here I'm going to end up with 22 hydrogens total. So now let's look at the oxygens. So for our oxygens, we had 6 in our original monosaccharide and another 6 in the other monosaccharide, but then one of them we removed and it became part of our water molecule. So we have to take that into account. We have to account for all of the matter, so nothing can disappear. Okay, it's all still has to be there somewhere. So in this case, we have 6 plus 6 minus 1, or 11 oxygens. So you can calculate the number of carbons, hydrogens, and oxygen as well in our sucrose molecule, but knowing it's a disaccharide, I'm pretty sure that we removed the same water, and they should be the same. So we're just going to double check. Right? So then, I haven't built my starch molecule, but here you're supposed to build your starch molecule, and you're coming up with the chemical formula again. Right? You just have to take into account that you built some water molecules. So if we start by looking at our glucose, our C6H12O6, okay, if we connect 4 glucose molecules, okay, if we connect 4 glucose molecules, well, in reality, we needed to form 3 chemical bonds in order to connect 4 molecules. So in that case, we should have made 3 waters. So something to take into account when you're accounting for your matter here. So I'm going to have you try and come up with the chemical formula for this, and we'll check it in class. So let's make sure and remind me if we forget to go over number 4. So then we're going to look at a few questions together. So we're looking at some words. So if we are looking at 3, so you should be able to complete 1 and 2 easily. 3 says, synthesis means putting stuff together. So putting together, in this case, molecules. Dehydration means the loss of water. Just like if you were dehydrated, it would mean that you were losing water. You didn't have enough water. Explain why chemists refer to the joining of monosaccharide molecules to form disaccharides as a dehydration synthesis reaction. So we're building things by losing water. So we have to consider the process, okay? So flipping back, in order for us to make this chemical bond between our 2 monosaccharides, we had to remove the water. Otherwise, there was no way for them to connect. Okay? So it's asking you to put that idea in your own words. So the only other thing I would want you to look at, and that I want us to look at together, would be thinking about 5 and 6. So 5 says the word carbohydrate is derived from carbon and water hydrate. So explain why that's accurate. So I want you just to look at that chemical formula. So we can just start with our monosaccharide and think about what the word means, okay? So carbon and water. Right, so why is it specifically called a carbohydrate? Then, for 6, it's talking now about breaking down larger saccharides, so disaccharides and polysaccharides, into those monosaccharides, which needs to happen in the body. So that's necessary in the body in order for your cells to get energy, so that our monosaccharides are able to move from the digestive system, from the small intestine, into the bloodstream. It says that breaking these parts apart is called hydra, so meaning water, lysis, which means to break apart. So I want you to consider that this process, so hydrolysis, is the reverse, so it's the reverse or the opposite of dehydration. So thinking about it now, in order for you to rebuild each of our monosaccharides, they would need to have they would need to react somehow with the water, right? Some sort of change would need to occur in order for them to be whole or complete again. So I want you to think about how that water, that hydrolysis would occur to break this disaccharide back into its monosaccharides. Okay? So hopefully that was helpful. We will discuss any questions in class. Please make sure that you finish all of the analysis questions. Okay, have a good day. Bye.